Congratulations on solving your clue. Now look and solve for max and min points. Let's head back to the HQ. So, let's solve for this critical point right here. -1 over root 3. We are going to plug it into our function and we're going to see what the y value is. This will be our first max or min point. By the way, this is my assistant here. She doesn't want to be named or shown. Isn't that fantastic? And here's our little Roo here, in the nice pouch of her mama. So, what we did here, we plugged in our number, and then we did some simple math, and then your result should be 3 root 3 over 2. That is going to be our y value. So therefore, we're going to plug in the other point here, and we're going to solve for its y value, and we'll see how they compare to each other, and we'll decide if it's a max or a min point. Let's solve it then. We're going to solve for our other critical point. 1 over root 3. My trusty assistant here will be writing out the solution for you. So let's see what she gets. So, we solved our point here using some math. We have a y value of -3 root 3 over 2. So now let's compare our 2 points and see which one's the max or the min. Let's solve for our max and min points. What we have here is just what we need to do is wait, what? Do you hear that? Sounds like almost. Oh no! Oh god! He's got me! Don't worry! I got it! Oh, this is how you wrestle a crook! 1, 2, 3. Well, that was fun, wasn't it? So, what we have here, recall our intervals of increase and decrease. If you need to remember what they are, click here. So, therefore, this point here has to be a local min, and this point here has to be a local max. We found our step. Let's move on and find the next clue. Off to find our next clue. I don't know how to drive. Bye. Ugh. Look here, mates. We found the last clue. Always ensure that you handle your weapons with care. Well done, stranger. You found all the clues. Now solve for intervals of concave up and concave down, and then find the treasure. let's solve for it right now.
The Oliver Jones Show, brought to you by Sprite. Tasteful and refreshing.
So, let's solve for concave up and concave down. If you want to solve for concave up and down, you must take your prime function and prime it again. Here's our primed function. You will use the product rule to find the double prime. You follow this process and you should end up with this right here. You set this whole function equal to 0 and you solve for any inflection points or restrictions. So we took this part here and we figured out that it never crosses the x-axis. We can prove this by using technology and graphing it. So, no inflection points, no intercepts. But for this here, we have restrictions. X cannot equal 0, 1, or -1. So, you now need to also, similarly to increasing and decreasing, draw a number line, put in any restrictions or inflection points. So in this case, -1, 0, and 1. And you need to plug in some numbers and see if it's greater or less than 0. In this cases, it is less than 0 here, therefore it has to be concave down. Here it is greater than 0, so it is concave up. Here less than 0, so concave down. Lastly, concave up. Put it all together, solve your intervals, and you should get this right here. So our function is concave up from -1 to 0, or 1 to infinity, and is concave down from -infinity to -1 or 0 to 1. We have solved every step that we needed to solve. We are going to go back to the HQ, graph our function, and find the buried treasure. This is so amazing!